Assalamu alaikum. I'm Zain Sultana. Today our topic is Caesar cipher and one-time pad. What is actually Caesar cipher means? If we want to send someone message and we want that only that person can understand our message and it should be confidential for others, so we have a special key that the other person can only know or access our message. Now let's see about details of Caesar cipher. Caesar cipher is one of the earliest known example of substitution cipher. It is said to have been used by Julius Caesar to communicate with his army secretly. It is a substitution cipher that ships later in a message to make it unreadable if intercrypted. Each character of a plaintext message is replaced by a character in position down in the alphabet. Now we have to know some basic terminology for understand the Caesar cipher more deeply. First, we need a plaintext, which is the original message. Then, we need the ciphertext, which is the coded message. Cipher is the algorithm for transforming plaintext to ciphertext. And we need a key that is info used in cipher known only to sender or receiver. Encrypt means converting plaintext to ciphertext, and decrypt means recovering ciphertext from plaintext. Cryptography is the study of encryption principles or methods. Cryptanalysis is mainly the code breaking, the study of principles method of deciphering ciphertext without knowing key. And cryptology is the field of both cryptography and cryptanalysis. Now we have some requirements for our Caesar cipher. Two requirements for secure use of symmetric encryption is a strong encryption algorithm and a secret key known only to sender or receiver. Then we can know Caesar cipher as C, plaintext as P, key we can represent as K, encryption we can represent as E, and decryption we can represent as D. Now, we will know more details about Caesar cipher that we can represent Caesar cipher as mathematically. We can mathematically transfer Caesar cipher. For this, first we have to convert the letters of the alphabet to numbers so that we can operate on them mathematically. Like we have 26 alphabet in English, A to Z. We will convert them into index number, that is A for 1, B for 2. Similar like this, Z for 26. We convert them for our mathematically representation. So this is our alphabet and its below is our index number. And we have some rules for the encryption and decryption methods. Now let's see what it will work. First, we have to choose a plaintext that will be the original message. Then we can applying Caesar cipher replaces each letter by third letter algorithm, and we have to use key for encryption. Now, suppose we choose a plaintext for encryption method, which is attack, ATTACK, and our key is 17. This is our alphabets or characters, and this is our below is our index number. From the plaintext attack, we can find our ciphertext as RKK RTV. Now, how we will get it? Let's explain more deeply. First, we have our alphabets and our index number, which is A for 1, B for 2, and similarly go for Z for 26. And we have some methods for our encryption. That is our Caesar cipher index equal to plaintext index plus key. Now let's see a table that will our plaintext index number, our key, ciphertext index, and ciphertext. Now we will explain how we can get our ciphertext from the plaintext. Our plaintext was attack A T T A C K. For this, our plaintext index is A. For A, this is 1. For T, this is 20. For T, this is again 20. For A, this is again 1. For C, this is 3. And for K, our index number is 11. This is our plaintext index number. And our key is 17, which is same for our all plaintext. And our rules was for encryption method is Caesar cipher index equal to plaintext index plus key. Our plaintext index is 1 and our key is 17. So our ciphertext index will be 17 plus 1 is equal to 18. Similarly, for T, plaintext index is 20 and key is 17, which is 37. Similarly, for T, 37. A for 1 plus 17 is 18. For C, 3 plus 17 is 20. And for K, our ciphertext index will be 11 plus 17 is equal to 28. So, now how can we get our ciphertext from this ciphertext index? For ciphertext index 18, we can see in the index 18, we can find the alphabet R. So we write down our ciphertext R for the ciphertext index 18. Then we will explain K later. First we say we got 18 again, and in 18 number we can get R again. In 20 number index we can get T, and now we have a question that for plaintext T, we can get the ciphertext index 37, but we have index only as 26. Furthermore, we don't have any index number and any alphabet. So what can we do now? And similar as for 28, we don't have any index 28. So what can we do now? Don't worry, we have some rules for this also. This is not so complicated, but we have to understand it carefully. For this, we have some rules that if our Caesar cipher index is greater than our index number, which is 26, this is for T, we can our ciphertext index 37, which is greater than our cipher normal index number. So then we have to divide our ciphertext index by 26. If our result in fraction, we have to minus the integer number from the result. After that, we can get a new result, and with this new result, we have to multiply 26. So we will be more clear if we see an example, like we can get 37 as our ciphertext index. So there is no index such 37. So first we have our ciphertext index 37, which is greater than our index number. So we divided it by 26. After dividing, we get a fractional number which is 1.423076923. Now we have to do that. We have to minus the integer value which is 1. So after minus this 1, we will get a number which is 0.42307692331. Now we have the result, and with this result we have to multiply 26. After multiplying this, we have get 11. This 11 is our main index value for cipher text. In 11 number index, we can get K. So K is our cipher text. And similar as T, and for 28, the process is same. Like when 28 is also the bigger index, which we don't have in our index value. So we have to divide it by 26. Then we will get an answer which is 1.0769230077. And we have to minus our integer value from it. After that, we will get the answer is 0.7692307692. And with this result, we have to multiply 26. And after that, we will get our desired index, which is 2. In 2 number index, we can find that there is the alphabet B. So this is the process how we can get the ciphertext from the plaintext. Now, let's see about the decryption method. For this decryption method, the formula is a little bit different, but little bit similar also. For decryption, we have rules which is how can we get our plaintext index? By minus our key from the ciphertext index. Now let's see how we can find or recover the main plaintext from the ciphertext. In previous, we can see that our ciphertext was RKKRTV. Now we have write down the ciphertext index, which is 18 for R, 11 for K, 11 for K again, 18 for R, and 20 for T, and 2 for B. Our Q was 17, and it is same for everyone. And after that, we have to follow this formula, which is our plaintext index will be ciphertext index minus key. So our ciphertext index was 18 and our key was 17, and the result is 1. So our plaintext index is 1. And similarly, 11 minus 17 is minus 6. 11 minus 17 is minus 6 again. 18 minus 17 is 1. 20 minus 17 is 3. 2 minus 17 is minus 15. Now we can see that in our 1 number index, there is present alphabet A. So we write down A. But we don't have any minus index number. So we will see how we can find the alphabet from this negative index number. First, we see that which index we have, which is 1 for A, and we get the index 3, we can write down the alphabet C for this index number 3. And now we have 3 negative index number, which is -6, -6, and -15. How we can get alphabet from this index? Because we don't have any minus index. So there we have also some rules. If our plain text index number is less than our total index number, then we have to follow some process. We have to find the multiply of 26, and we have to dividing plain text index by 26, and we have to apply a formula which will be x plus 26 into multiplier of 26. We can know the more details from an example. Now let's see the example that we have -6. For -6, what can we do? We have this formula. In the place of x, we will replace this negative index value. First, we have to find the multiplier of 26 for this -6 index value. First, from the 11 ciphertext index, and we can minus the key 17, which is -6. And now we have to find out the multiplier of 26. How can we find it? We can find it from the index we have get, which is 6. We have to divide it with 26 because we have 26 index number in total. After dividing 6 by 26, we will find 0.230 and ... which will be in uppercase is 1. So our multiplier of 26 is 1. In our formula, we have write down -6 as the place of x, and we have to add plus we have 26, and the multiplier of 26 is 1. From this formula, we can get the answer is 20. And we have this index, so for the index 20, we can get the alphabet T. And for 15, we can follow the same rules. For -15, we can see this. 2 minus 17 is -15. And after that, we have to find the multiplier of 26, which we can find out by dividing 15 by 26, which will be 0.576 ... In uppercase, it will be 1. And in our formula, we have to write down -15 at the place of x. Then we have to multiply our multiplier of 26 with 26 and add it with -15. Then we will get our result as 11, and we have this 11 number index. So our 11 number in our 11 number index, we will get the alphabet K. So we write down K there, and we get our plain text again, which is ATTACK, attack. Now this was the concept of Caesar cipher. Now we will talk about one-time pad. One-time pad is nothing more a upper version of Caesar cipher. The everything is same except some additional things. Like we have this index and alphabets, numbers. Then we have the same encryption formula as our Caesar cipher. Now, in this one-time pad encryption method, we have a difference in our key. Suppose our plaintext is apple, which is APPLE, and in our ciphertext index, we decided our key was a number. But in this one-time pad, our key is not a number. It is a string, and it can be any type of a string. So we can find that in this, our plaintext is apple and our key is elephant, which is more large than our plaintext. So how will we find that which key we will take for our plaintext or from our ciphertext method? So if we have elephant, which is 9 alphabets, but our plaintext has only 5 alphabets. So in this case, we can take only first 5 alphabets, which is ELE, P, H, because we don't need more. So this A and T is not needed in this case. And there should be a question that if the key is less than our plaintext alphabets number, so what can we do? So if we find that our plaintext is apple and if our key is cat, which is made of 3 letters, so what can we do now? Now the first letter will be repeat again until it match with the number of our plaintext alphabets. So if our key is cat, it will be a circle and the C will again come, A will again come, and if our letter is more than 5, then T will again come and C will again come. It will be round as circle. And the other formula is as same as our Caesar cipher method. For encryption method in one-time pad, the formula is same, which is our plaintext index plus our key, which is 1 plus 5 is equal to 6 for A. For P, it is 16 plus 12 equal to 28 for P, which is 16 plus 5 equal to 21 for L, which is 12 plus 12 is equal to 24, and for E, which is 5 plus 8 is equal to 13. For this, in 6-number index, we can find the letter F. In 28-number index, we have to calculate. In 21-number index, we can find the letter U, and in 24-number index, we can find the letter X, and 13-number index, we can find the letter M. For 28, the formula is same. We have to divide 28 by 26. We can get a fractional number which is 1.076923077. We have to minus the integer value which is 1 from the result. Then we will get the result 0.76923076992. And we have to multiply 26 with the result. Then we will get our desired index number, which is 2. For 2, we refers the letter B. And this is all same for our decryption method. There is no change. For the decryption method, the rules was ciphertext index minus k, and all about the Caesar cipher method, it is same. For this, for f, our plaintext index is 1, which is 6 minus 5, which is 1. For b, 2 minus 12, which is 10. For u, 21 minus 5, which is 16. 24 minus 12, which is 12. And 13 minus 8, which is 5. So, for 10, which is exceptional, we can follow the same rules as Caesar cipher, that we have to find the multiplier of 26, which we can get divided by 10 with 26, we get 1. So our multiplier is 1, and with this we can find the index number 16. So we can find out the plaintext again. This is all similar as Caesar cipher. So now we can hope that it is clear to all. Now we can see the code of our Caesar cipher. In this code, we can see that we have to take our characters in string, key in int, and we have our order character from which we minus 65, as 65 is the ASCII value for capital letter A, which is understandable for the computer. And our main code was our character code plus key, and we have to divide it 26, and the remainder is our main index number from which we can get our plaintext to ciphertext and also our ciphertext to plaintext. So here is our code, and in the last of our code we have decorated it smoothly, so we can find the result as if we write down our plaintext is attack at dawn and enter the key of 17, we can get our ciphertext as RKK RTB RKUNRA, and we will return the plaintext again for attack at dawn, which is clear to all. And for our one-time pad, it is only the updated version of Caesar cipher. There is not more differences. It is almost similar. The main code is similar, and in our ciphertext, we take our offset as 67, which is the ASCII value of A, and 97, which is the ASCII value of small a. And our result, our main formula is same, our character number plus key divided by 26, and we have find out the remainder. And from this remainder, we can find out our index number from which we can convert our plaintext to ciphertext and our ciphertext to plaintext. This is the output of our code. If we take plaintext as apple and enter the key elephant, we will get the ciphertext EATAL, and if we convert it or decrypt it, we can find the apple again. So this is all about our Caesar cipher and one-time code. I really hope that you guys understand it well. So that's all about my presentation. Thank you everyone.